Number 1. When examining the formula of a function that is the result of multiple transformations, how can you tell a horizontal shift from a vertical shift? So typically they're written in this form: y equals some constant a times the function f of x plus or minus h plus or minus k. Alright. Now, when it's written like this, you can get it into this form. If it's not that way already, you can use some algebra and manipulate it and get it into that form. And the h here, the constant h, which goes into the input, added to the x, determines horizontal shift. Think of the x-axis as being horizontal and the shift is horizontal. Alright? The k here is vertical shift. Now it's easier to remember like this if you write it like this: y plus or minus k equals a times f of x plus or minus h. If you move the k at the end of the function to the left side, put it next to the y, then it's easier to remember this. Alright, the k next to the y tells you it's a vertical shift because, well, think of the y-axis as being vertical. Alright, so even though this may look a little strange or awkward, it is easier to remember this way if you write it like that. And the h next to the x tells you horizontal shift. Think of the x-axis. Alright, number 3. When examining the formula of a function that is the result of multiple transformations, how can you tell a horizontal compression from a vertical compression? Alright, so in general it'll be written like this, or you can get it into this form: y equals some constant a times f of x divided by some constant b. Another way of writing that is y, divide both sides by a here, y divided by a equals f of x divided by b. Alright? Now, if it's not written in this form already, you can get it into this form using a little algebra. So this a, constant a under the y, tells you the amount of vertical stretching or shrinking going on. Think of it as being under the y, and think of the y-axis as being a vertical axis. So that suggests vertical stretching or shrinking. Similar thing occurs with the b under the x in the input here of the function. Alright, the b will tell you the amount of horizontal stretching or shrinking going on. And think of the b being under the x. The x-axis is horizontal, so that suggests to you a horizontal stretching or shrinking. Now if b is between 0 and 1, then it's going to be a compression, a horizontal compression. Alright? And a vertical compression occurs when a is between 0 and 1. Okay. For example, let me just deal with the horizontal compression. Let's say we have y equals f of, let's say, 3x. Now that's a horizontal compression. And you're saying, maybe you're saying, well, wait a minute, there's a 3 in front of there. Well, it's got to be dividing here. We've got to get it into this form before we can tell, okay? So, use a little algebra here. This is f of x divided by 1/3, correct? These two are equivalent, right? You flip that fraction over, multiply by the top, that gives you the 3x. So this is equivalent, and that 1/3 is between 0 and 1. That's your b in this formula. And that 1/3 tells you it's going to shrink horizontally or compress horizontally by 1/3. That is, the original function, f of x, will be horizontally compressed by a factor of 1/3. Okay? So that's basically it. Okay, number 5. How can you determine whether a function is odd or even from the formula of the function? So what you do is you substitute negative x into the input of the function. Alright? So basically f of negative x is what you want to evaluate. See what happens when you do that. Alright? If the result equals f of x, that means the function is even. And if f of negative x gives you negative f of x, then the function is odd. Alright? So if you have an even function, as an example, parabola is an example of that. There's x, and let's say that's negative x. So that's, if that's x, that's f of x right there on the y-axis. So f of x, or f of negative x, equals f of x, correct? F of negative x equals f of x. Alright? That's f of x there, and that's f of negative x. They're both the same. Okay? Now if you have an odd function, good example would be y equals x cubed. So here's f of x, well here's x rather. There's f of x. So if that's x, this, let's see, right here is about negative x. And that's negative f of x, alright? If that's f of x, that's negative f of x, okay? So if that were 2, that would be negative 2, okay? So f of negative x, right there, f of negative x, right there, right there, is equal to the negative f of f of x, alright? So that's an example of an odd function, like y equals x cubed. Okay, number 7. Write a formula for the function obtained when the graph of f of x equals absolute value of x is shifted down 3 units and to the right 1 unit. Okay, down 3 units to the right 1 unit. So let's take the graph, or the formula y equals absolute value of x. Alright. If I want to go down 3, I would write it like this. Y minus negative 3. That minus, the way I'm doing this, the minus will always be there. So if that were a y minus 3, positive 3, the shift would be up, 3 units up. All right? But since it's a negative 3, it's 3 units down. And I'm thinking up and down because it's next to the y. Think y-axis is vertical. All right? That equals absolute value of, let's see, the shift is to the right 1 unit, x minus 1. So x minus some constant, all right? If this constant were negative, if it were x minus negative 1, of course it would probably be written as x plus 1. But you can write that as x minus negative 1, and the shift would be to the left, all right? But since this is a positive 1, the shift is to the right. Notice the consistency here, y minus, x minus, all right? If y minus something, if that something is negative, the shift is down. If that something is positive, the shift is up. Similarly here, x minus some constant, if that constant is negative, the shift is to the left. And if the constant is positive, the shift is to the right. So here, x minus a positive constant 1 is to the right 1 unit. And here, y minus something that's negative, the shift is down. All right. So I know your book doesn't show it this way, but this is a nice, easy way to remember it, I think. However, most likely it's going to look like this. This is going to be y plus 3. If you subtract 3 from both sides, you got y equals absolute value of x minus 1 minus 3. All right, that's, or f of x, we can call it f of x, since that's the notation they originally used. So that's probably the way your book will answer it, and most people will answer this. But notice that this is equivalent to what I have here. So again, if you see it written like this, and they're saying what kind of shifting is going on, you can write it this way, and then see immediately what kinds of shifts are going on. All right, up, down, left, or right. Okay, number 9, write a formula for the function obtained when the graph of f of x equals 1 over x squared is shifted up 2 units and to the left 4 units. So I'm going to write that as y equals, because I like to think about the y-axis, 1 over x squared. It's helpful to think of the x and y axes when you're doing these transformations, all right? You can always write y instead of f of x. And so let's see, it's shifted up 2 units. Up. So you write that next to the y. Think up and down. Y-axis is vertical. And you always write it as y minus something. All right? If the something is positive, the shift is up. If the something is negative, the shift is down. All right? So it's shifted up, so it's y minus 2. Up 2 units. And later we can rework this, massage it a little bit and get it into the form that the book's answer expects, but it's equivalent. And now 1 over, let's see, it is shifted to the left 4 units. So that's to the left, that's going to be next to the x. Think x-axis horizontal, all right? And it's going to be right next to the input of x. So you put that in parentheses. And it's 4 units left, so it's going to be negative 4. So you write x minus negative 4 squared, like that. So remember, it's always y minus x minus, and then whatever that number is, the constant. So since it's a negative constant, it's moving to the left, shifting left. This would normally be written as x plus 4, of course, but for the purpose of remembering how the shifts are working and how these constants are working, we write it like this, x minus y minus, all right? So that's basically it. That's basically it. But we can get it into the form that they're expecting. Alright, so let's call it g of x, since it is actually a different function. Alright, from f of x. So you can add 2 to both sides, and then change that to an x plus 4 quantity squared. So you've got 1 over x plus 4 quantity squared plus 2. Alright. So that takes the original function f of x and gives you a shift to the left 4 units and up 2 units. Number 11. For the following exercises, describe how the graph of the function is a transformation of the graph of the original function f. So on number 11, original function we'll assume is y equals f of x. And now what we have is y equals f of x plus 43. Like that. Change that to f of x minus a negative 43. So now this tells you, since this number is in the input next to the x, it's going to be a shift to the left or to the right. Think x-axis is horizontal, so any shifts along that axis are left or right. It's going to be to the left though, because it's a negative 43. Alright, so we have a shift to the left of f of x by 43 units. Okay, number 13, y equals f of x minus 4. So we take f of x, y equals f of x, and now we write f of x minus 4. So x minus something, right? That something is positive 4. So that means you're going to have a shift to the right. Right, why right? Because it's next to the x, the input there. Think x-axis, right? Horizontal. So 4 units to the right. Shifting, okay? So you shift f of x 4 units to the right. That's what you got there. Okay, number 15. Y equals f of x plus 8. The 8 is on the outside of the input. It's not in the input. Y equals f of x plus 8. I can write it in the form y minus a constant. Just subtract 8 from both sides, so you've got y minus a positive 8 equals f of x. And writing it like this, it tells me immediately what's going on. Okay, so it's next. This constant is next to the y. Think y-axis as being vertical, so we're talking about a vertical shift, up or down. If this constant here is positive after the minus, written as y minus, if it's positive, which it is, then the shift is up. If it were negative, for example, if this were written y plus 8, you would change that to y minus a negative 8. And the negative 8 would tell you it's a shift down. Okay. So if it were y plus 8, it would be a down shift. If it's y minus 8, it's an up shift. Okay, so it's a shift up by 8 units. Okay, number 17. Y equals f of x minus 7, and that minus 7 is not in the input. Y equals f of x minus 7. So you can think of adding 7 to both sides. Change that to minus a negative 7. Which is equivalent to plus 7, right? So these two are equivalent. So written like this tells me immediately what's going on. So the number here is next to the y. Think y-axis is vertical, up or down. So it's going to be an up or down shift. Since this number here is negative after the minus here, written this way, Negative means down, so it's going to be shifted down 7 units. All right. Okay, number 19. Y equals f of x plus 4, and then minus 1 outside of the input. So y equals f of x plus 4 minus 1. So first you can add 1 to both sides. Y plus 1 equals f of x plus 4. Now you change it to minus here and minus here. Make it equivalent. Y minus negative 1, which is the same as y plus 1, equals f of x minus a negative 4, which is equivalent to x plus 4. Alright? So written this way, it tells us immediately, without too much memorization, what to do. Alright? Which is very nice. So this, next to the x, think x-axis, left and right, horizontal, correct? So this is a negative 4. That means it's going to be a shift to the left 4 units. And this is next to the y. Think y-axis as up and down, vertical. And since this is negative, that means the shift is down. So you have a shift down 1 unit and a shift to the left 4 units. Okay? Okay, number 21. For the following exercises, determine the interval or intervals on which the function is increasing and decreasing. So we have a function here, g of x equals 5 times the quantity x plus 3, square that, minus 2. Alright, so first let's let y equal g of x. Then what we have is subtract or add 2 to both sides to y plus 2 equals 5, parentheses. I'm going to write that as x minus negative 3 squared. And then divide both sides by 5. And I'm going to write that as minus a negative 2. Now the original function is y equals x squared. You can see that? And these constants transform y equals x squared. Okay, so what kind of transformations are we getting? Y equals x squared, of course, is a parabola which opens upwards. Alright, it still opens upwards because that's a positive 5. Alright, so what does this tell us? Over here, this is going to be a vertical shift. That is a downward shift by 2 units. Okay, this 5 will give us a vertical stretching by a factor of 5. All right. If that were, let's say, a 1/5 there, and you divided both sides by 1/5, that would be a 1/5. That would be a vertical compression. Okay, by a factor of 1/5. All right. So anyway, over here we've got a shift to the left 3 units. All right. So this number again is next to the x. Think x-axis, horizontal. This number is next to the y. Think y-axis, vertical. Same with this. Anytime you divide by these numbers, you're going to get a stretching or shrinking. All right, and these will give you your shifting, left, right, up, or down. Right, these constants. Okay. So the usual vertex for this, y equals x squared, the vertex is the origin, 0, 0, for y equals x squared. But this one has been shifted left 3 units, think of that vertex being shifted left, so just add -3 to that 0 there. So the vertex of this is going to be -3, and then there's a downshift 2 units, shift down. So the vertex goes down 2 units. You just subtract 2 from the y coordinate here, and you get -2. So that's the new vertex. All right. So think of shifting it left and down. Okay. Now I could draw a little picture of that, make it easier to see where it's increasing and decreasing. 1, 2, 3, 1, 2. So here's the vertex. The 5 here is going to cause a stretch, and so my graph is no doubt inaccurate, but we don't really need to worry about that in this problem. All we need to do is see where it's increasing and decreasing. So it's decreasing from -infinity to that point right there, which is -3. All right, so it's decreasing on the interval from -infinity to -3, and it's increasing after that, right? Here's -3, and then it starts to increase. So it's increasing on -3 to infinity. Right like that. Number 23. We have k of x equals -3 squared of x minus 1. K of x is -3 squared of x minus 1. All right. So let's let y equal k of x. So we have y equals -3 square root of x minus 1. So add 1 to both sides. Y plus 1 equals -3 square root of x. And change that to a minus and -1. And then also divide both sides by -3. And that'll move that away, and you just have square root of x. So basically you're taking the function y equals square root of x, which I drew over here, and you should remember what that looks like. But here's a typical point on there, 4, 2. Let's see what happens to that point when we do these transformations. Alright, so what's going on here? We have a reflection because that's negative. Alright, but first of all, let's look at this number, just the 3 by itself. Alright, it's under the y here, so it suggests a vertical, since y is a vertical axis, a vertical stretching by a factor of 3. Alright, however, the negative will cause a reflection. Think of reflection flipping across like this, vertically, a vertical reflection, like that. It's going to be across the x-axis, okay? So the reflection is across the x-axis, which is horizontal, and it's going to be a vertical, think of a vertical flip like this, since it's under the y. If it were under the x here, dividing the x, then think of a horizontal flip across the y-axis, all right? Or a horizontal reflection like this, okay? So if you visualize that in your mind, you won't go wrong, okay? And then we also have a shift down 1 unit, all right? That's next to the y here, and it's negative, so it's going to be a shift down 1 unit. So what happens to the point 4, 2? Well, all you have to do with that point, with this formula here, is, since this is under the y, just multiply the y coordinate by -3. Alright? So instead of 4, 2, let me take the original 0.42. And that transforms to 4. And then negative 3 times 2 is negative 6. Okay, so that is what that does, the negative 3. Multiply that y-coordinate, and you get that. And then you're going to shift down, in other words, add negative 1 to negative 6, the y-coordinate. So you're going to get 4, negative 7. All right? So it's going to be way down here, but we'll just pretend this is 4, negative 7. All right, now what about the point here, which is 0, 0? All right, what happens to 0, 0? So the 0 here is multiplied by negative 3, the y-coordinate there, and that's still 0. All right. So the reflection here and the stretching has no effect on 0. All right. However, add negative 1 to 0 and you get 0, negative 1 here. All right. So this moves down to negative 1. So we're going to get something like that. It's very poorly drawn, but you get the idea. All right. So whatever this number here is, you take a typical point on the original function, multiply the y-coordinate by that, and then add that to the y-coordinate after you've done the multiplying or the multiplying here. All right. And similar with the x, if there's things going on here, all right, you would do something similar to that. All right. Okay.